Welcome to the third part of the heat series. In this video, we are going to learn about the various effects of heat and their practical applications. So, without any further delay, let's soar the sky. Videos of heat, the first and the second part, we have already learned about heat always transferred from a hotter body to a colder body. If two bodies are kept in contact with each other, heat will always flow from the body of a higher temperature to the body of lower temperature. This is called the transfer of heat. So let's come to the definition of the transfer of heat. When heat flows from a body of higher temperature to a body of lower temperature until both the bodies attain equal temperature, it is called the transfer of heat. Now, the transfer of heat occurs in three basic processes. The three processes or the three ways by which heat gets transferred from one body to another are number 1, conduction, number 2, convection, and number 3, radiation. We will come into each of these processes into details. So let's talk about the first process of transfer of heat, that is conduction. What is conduction? Conduction is that process of heat transfer where the heat energy passes through the particles of a medium or from one body to another, which are kept in direct contact with each other. And while the heat energy passes through the particles, they don't move from their position. It does not cause any movement of the particles of the medium. So let's go to the definition of conduction. The process of transfer of heat from the hotter part of an object to the colder part of an object without the movement of the particles of the medium is called conduction. From their position, the particles won't move. Now, conduction depends upon two factors. Since it does not move the particles of the medium, then the particles have to be very close to one another so that the heat energy can very easily travel within them. So the first factor on which conduction depends upon is how close the particles of the medium are with each other. Now this point is very crucial as this gives the states of matter how they will conduct the heat through themselves. Since the closeness of the particle is a factor to the process of conduction, so we can very easily say solids are the best conductors because they have the particles very closely attached to each other. You can almost say there is a negligible intermolecular space in between the particles of a solids. Then comes the liquid and then the gases. Since liquid have a little bit more intermolecular space in between them and gases have a lot of intermolecular space between them, so the conduction occurs best in solids, then in liquids, and then in gas. So how does conduction actually takes place? Let's look at this diagram very carefully. This is an amplified diagram of a solid and the particles which are closely packed inside it. In a solid, if say for example we apply heat at this particular point, now the particles inside the solid being very closely attached to each other will start vibrating in both sideways and up and down. This vibration will cause a little bit of collision and that vibration will pass on to the next particle and the next particle, and this is how this collision and vibration will cross throughout the solid, throughout the entire medium of solid. Each and every particle will start vibrating and colliding with each other, and the heat starting from here will come to here, heating up the entire solid. This is how conduction occurs without any movement of the particles, and hence it is the best in solid. I can explain the process of conduction to you in a better way by showing this practical example. See, I have a spoon, steel spoon in my hand, and I also have a lighter in my hand. If I take this spoon and light up this lighter and keep the heat here, I am heating the spoon. A time will come when I will no longer be able to hold the handle because the heat will get transferred by the vibration of the particles till the colder end. This is the hotter end where I am applying the heat, and the part where I am holding the spoon is the colder end. A time will come when I will start feeling the warmth of this heat, and after a certain period of time, I will no longer be able to hold it. That is right now. The rate of conduction of various medium are different. It depends on the material of the body. So, on the basis of that, the materials can be divided into two categories: the conductors of heat and the insulators of heat. Let's see what they are. The conductors of heat are those materials that allow heat to pass very easily through them. The materials that allow heat to pass very easily through them are called the conductors of heat. The examples would be any metal or any alloy. They are very good conductors of heat. The properties inside them are such that they allow heat to pass very easily through them. The next is the insulators. What are insulators? Those material that does not allow heat to pass at all through them, that does not allow heat to pass through them, are the insulators of heat. The example would be wood, cotton, rubber, clay, plastic, etc. Now you would ask me that wood catches fire very easily, same goes with cotton, then how can they be insulators? Now don't get confused between normal heat energy and fire. Fire occurs only the heat is up to a certain period of time. I have already explained what is fire and its details in the first part of this video. So please go ahead and check that. Now I will tell you two very practical examples or application of conduction. The very first is the kitchen utensils. You will be able to see, if you notice in your kitchen, the pans or the cauldrons like this. The body of it, the body, see, it is made of steel or any kind of metal or iron. Some utensils are made from iron also, brass also, so, and different alloys as well. This is made from steel, but if you see the handles, these handles are made of plastic. Metals and steel or alloys are very good conductors. So the body is made by the metals or alloys so that it catches heat very fast and cooks the food faster. But the handles are made from plastics because plastic is a very good insulator. It will prevent that heat to reach up till the handle so that you can hold the handle safely while cooking. Another practical application of heat is wool. What is wool? Wool is a very good insulator. The fibers of wool traps the air from outside as well as from inside. So, if you see a woolen garment which we wear during the winter season, in between the fibers of the wool, the air or the body heat is trapped. It does not allow the heat to pass from inside to outside. So this is how wool prevents the body heat to go outside by insulating it. The second process of transfer of heat is the convection. Convection is exactly the opposite of conduction. While conduction does not require the movement of the particles while passing of heat through them, convection depends on the movement of the particles to transfer the heat. Let's come to the definition. The transfer of heat by the movement of the heated particles of the medium is called convection. As convection depends on the movement of the particles, so naturally it will be most in the fluids where the particles move very easily. It occurs mostly in fluids, that is both liquids and solids, where the intermolecular space is huge. The particles, the molecules can easily pass and move around. So how does the convection occurs actually? Let's find out. Here in this diagram, it is a diagram of any fluid. It can be a liquid or it can be a gas as well. Say for example, if we heat it up at the bottom, what happens is the molecules which are at the lower part, they becomes very light when they receive the heat energy. So lighter molecules starts floating upwards. Okay. And the molecules which are at the top, they are comparatively colder to these molecules. So they in turn comes down, they are heavier as well since they are colder. So they come down to take the place of these lighter and hotter molecules. And these cycle constantly goes round and round and round. This is how, while the lighter molecules goes up and the heavier molecules comes down, this is how the entire medium gets heated up, and this is how the process of convection occurs. Here you can see the water is boiling and the heat catches up with the lower molecules of the water first, below its surface, and then what happens is the lower molecules being lighter, they starts rising up, and the colder molecules of water being at the top of the surface, they come down to take its place. As this process continues, there is a current produced as they produce a jet stream of water and a current is produced, and this is also known as convection current. Let's come to the two very practical applications of convection that occurs in nature every day. They are sea breeze and land breeze. Now let's know what are these. Sea breeze is a completely different thing than land breeze. Sea breeze occurs during the daytime. What happens is in the coastal areas, during the daytime, the hot rays of the sun heats up the land way faster than the water, that is the sea. As the hot air above the land gets warmer and hotter, it becomes lighter, and being lighter, it starts to rise up. And the comparatively colder air which is above the sea rushes to take its place. If you see the diagram, you can very well understand the air above the sea is colder and the air above the land is hotter. The hotter air above the land being lighter rises up, and the colder air above the sea rushes to take its place, and this air is called the sea breeze, and this continues during the daytime. So let's come to the definition of it. During daytime, first important point, the air above the land gets warmer and rises up. Immediately the colder air above the sea rushes to take its place, and this air is called the sea breeze. So what is land breeze then? Land breeze is exactly the opposite of sea breeze. While sea breeze gives you a cooling effect, it's good for the summer days. Just beside the sea, you get a cooling effect of the colder air above the sea. But land breeze, the first point of difference from the sea breeze is it occurs during the night time. While the sea breeze occurs during the daytime, land breeze occurs during the night time. What happens is the land takes time to, as the land gets hotter faster than the sea, but it cools down faster than the sea as well. The water takes time to heat up, and it also takes more time to get cooled down, to lose that heat. Comparatively, the land gets heated up faster and gets cooled down faster as well. So here what happens is during the night time, the land loses its heat way faster than the sea. So now the situation is completely opposite. The air above the land is colder while the air above the sea is hotter. The hot air from above the sea rises up being lighter. Similarly, just it happens during the daytime, during the sea breeze, the land has the colder air now. The air above the land is colder now. So it rushes to take the place of the sea breeze, and the warmer sea breeze comes towards the land. So here is the diagram where you can see during the night time, the land loses its heat faster than the sea, and the sea the air above the sea is still hotter. So it's lighter, it's getting up, and the colder air from the land is rushing to take its place. So this warm air that is coming from the sea to the land helps us to keep warm during the winter, and the hotter air from the land which is going towards sea, this is called the land breeze. So let's see what is the definition. At night, the air above the sea is warmer, so it rises up, and the colder air, as the land gets cooled faster, the colder air above the land rushes to take its place. This air, the air above the land that is rushing to take place, the air above the sea, this air is called the land breeze. Two more practical applications of convection are, number one, exhaust fans. If you see in your kitchen or in your washrooms, the exhaust fans are generally fitted at the top of the wall. Why? Because the hot air that is produced inside the kitchen while cooking, or the hotter air that is produced in the washrooms as well, they rise up. So if the exhaust fan is placed at the top of the wall, it will be easier for the exhaust fan to remove those hot air instantly. During winters, the room heaters are always placed at the floor of the room, and here comes our second practical application of convection. Why do we put the room heaters on the floor during winters? Because the hot air produced by the room heater will rise up and the colder air inside the room will come down, and this constant cycle of convection will result in heating up the room way faster. Heat energy can travel in the form of waves as well. Okay, and these waves does not require any kind of medium to travel or pass through. This concept gives us to the last but not the least form of the transfer of heat, that is radiation. Let's first look at the definition of radiation. The transfer of heat in the form of rays or waves without requiring the particles of any medium is called radiation. This is the definition where we can very clearly see the heat is transferring in the form of rays or waves, and they do not require any involvement of any particle of any medium. That is, they do not require any kind of medium to pass through. This form of transfer of heat is called radiation. A very good example would be solar radiation. Now, we feel the heat of the sun rays during the daytime. How do we feel that? The sun is so far away from the earth. Then how does the rays of the sun reaches to us while we are so far apart? This happens by solar radiation. Since radiation does not require any medium to pass through, it is not obstructed by any medium as well. No medium can obstruct the radiations. If that would have been the case, we wouldn't have received the sun rays so far away. Okay, now all hot objects radiate heat. When heat gets absorbed or heat falls on any object, a part of it gets absorbed and the rest of it is reflected back. How much an object would radiate out heat, that depends on several factors. I can name a few of them. Say for example, how far the object is from the source of heat is a very good factor. The second good factor would be what is the nature of the object. And another two things to be noted down is dark colors are very good absorbers and light colors are good reflectors or poor observers. I can give you a good example. In the deserts, if you find people who live in the deserts, they generally wear white clothes. Why? Because the harsh rays of the sun and the extreme heat gets mostly reflected or radiated from the light colors. But if they would have worn dark clothes, that extreme heat and the light would be very easily absorbed by their clothes, making them difficult to live. While in the colder countries, if you see, people generally wear dark colors so that the little sun ray that they receive is absorbed very easily by those dark colored clothing and keep themselves warm. Now we will learn about the working of a thermos flask that that prevents the heat loss both by conduction and radiation. What is a flask? A flask is that device which helps to keep the hotter objects hot or the colder objects cold. That is, it prevents the loss or the gain of heat. It retains the temperature of the liquid that is put inside it. Let's see this diagram very carefully. If you see this diagram, outer casting of the wall of the flask, the outer wall of the flask can be made either from plastic or from any metal or alloy or steel. What happens is this prevents, if it's made from plastic, it will prevent the heat loss from any kind of conduction from outside. If it's touched with a colder object, the hot fluid inside it won't be affected anyhow, or if it's touched by any hot object, the colder liquid inside it won't be affected. The third point is, inner layer of the flask, if you see in the diagram, it is double walled. It has two walls. It is double walled, and it's mostly made from glass or sometimes made from steel as well. These two walls are polished a lot so that they are very shiny and they are very good reflectors or radiators. So they also prevent heat from any kind of heat loss due to any kind of radiation. The third point, in between these two layers that you see in the diagram, in between these two layers, there is vacuum. Vacuum between the two walls. Why? Because it prevents the heat loss by conduction, since there are no particles in between the two walls. So if air is present, the particles in the air might cause heat loss via conduction. Vacuum prevents any kind of presence of any particles in between the two walls so that conduction will not occur. Not only this, the thermos flask also prevents heat loss from convection as well. How? The cap right on the top of the flask, if you see in the diagram, this cap is made in such a way it seals off the container completely, preventing any loss from convection as well. This is how the fluids inside a thermos flask retains their temperature without losing heat via conduction, convection and radiation. So here we come to the end of the heat series. A like and a sub to our channel will be extremely encouraging for us. We are bringing up a brand new series quite soon. Till then, keep soaring.